So in this video we want to take you through quickly the operation or setup and operation of the new VF V23 interface for the Ether.Genius. With this interface we can perform delay measurements such as round-trip delay and one-way delay measurements, but also we can perform bit error rate testing. The interface actually is very similar to that, or the operation is very similar to that of the X21 and C3794. So if you're used to those interfaces or setting up those interfaces, then this will look very familiar. So the first thing we want to do on the Ether.Genius is make sure we're at the home screen, and we do that by pressing the home button on the unit or clicking on the house icon on the front of the screen. And then we want to go into the system menu. The first thing we always do on Ether.Genius when we're setting up a new test, a new configuration, is to do a reset to factory settings. So we just want to scroll down here to the reset to factory settings, press enter, and scroll down to the yes selection, and you should see on the screen it goes from yes to no. Okay, that says now that we've reset the unit to factory settings. What this actually means is I haven't actually cleared everything out in the unit, but we've cleared out the test and the setup menus. So basically we've zeroed out the test settings menus back to a default position. So we click back on the home button or the home key, and now we've done that we're going to go into the setup menu. Now when you do a reset to factory settings, it will start off and go back to Ethernet endpoint mode. So we want to click on the mode button here, and we want to scroll down until we find the Datacom endpoint, and we're going to select Datacom endpoint. Now why are we using Telecom endpoint? Well, the VF adapter, as some of the other adapters that are used on Ether.Genius, use the Datacom port on the Ether.Genius on the bottom of the unit, and that's why we have to select Telecom endpoint. Once we've done that, we can then go down to the actual Datacom selection and into the line selection, and this is where we can select the actual type of Datacom interface we're going to use. Now this is actually already set to V23, but if you're using a different interface like V11 or V24, etc., you can select that here. But we just want to make sure we've got the V23 adapter selected, which we have. And there really shouldn't be any need to change anything else here, because if you've got V23, for example, the line rate is automatically set to 1200 bits per second. So there's actually no need to change anything else. So we can hit the escape key, go back up a layer. Once again, there's nothing really to change once we've set that it's the V23 interface. There's no encapsulation. There's the test pattern is the default test pattern. So we hit escape again, or the home button to take us back up to the top menu. Now one thing we may want to select here, depending on what type of test we're doing, is the reference clock. Now actually for a round-trip delay measurement we don't need to use the external clock, the external GPS signal. Same thing for BERT testing. We only need to do this if we're doing one-way delay measurements. But we're just going to go in here quickly show you how it's done. Obviously you need to be connecting the GPS aerial, the GNS aerial, to the unit. Make sure that you've got that close to a window outside, so you've got line of sight, so that pick up the satellites. You then go into the reference clock setting here. Normally it's set for internal. We're going to go into that menu selection and we're going to select GNSS. This will then switch and try and use the external GNSS GPS signal. You can see down the bottom here that the oscillator is warming up. Hasn't actually locked a signal yet. We can always check what's happening with the signal by clicking on the LEDs button, either on the front panel or on the screen. And you can see here at the top the clock LEDs. We've got a reference signal. That means we've got an input signal from the GPS aerial, but it isn't locked to that signal yet. It takes a couple of minutes to lock on and get an accurate time reference. So that will go green once we've got that lock. So I'm just going to exit that for the moment. We can hit the escape key once again. We can go back up to the top menu. So really that's the basic setup for the V23 interface. Now we want to set up the tests, so we go into the test menu, and in this case we're going to do quickly a delay test. So we go into the delay test menu, we're going to enable that, select down here, and then we can select the type of measurement that we're going to make. In this case we're just going to leave it as round trip delay. measurement. If we were doing a one-way delay measurement between two units, then we would go in here and select one way, but we've only got one. I've only got one unit here, so I'm just going to do a round trip delay measurement. Now, with any delay measurements, we need to calibrate the inherent delay out the unit. What does inherent delay mean? It means that, from receiving the GPS signal, processing that, and sending it out to the particular interface, whatever that may be, there is an inherent delay in the unit, also in the receive side of the circuitry. So we need to calibrate that delay out. So on the VF interface, I've got the VF interface plugged into the DTE port, by the way, on the bottom of the unit, and I'm just going to loop the cable connected to the VF adapter. I'm going to do that by connecting the black and red banana plugs, 4mm plugs, to each other. It doesn't actually matter which one's connected to which, because the transmit and the receive will just be looped to each other. So just connect one black and red banana plug to each other, and do the same on the other one. And then we go down to this Adjust Zero Offset menu, go into it, and we're going to scroll down to the Adjust, and we're going to hit that, and then we get a measurement. And this is our inherent delay inside the unit. So don't worry too much about that figure. That's just the delay that it's measured, and it's now going to subtract that value basically from any delay measurements that we make. So we can press the home button now. We've calibrated that. We can hit the home button. We can now go into our test results. Just go hit escape and go back up to the top level. We're going to go down to the. By the way, if you hit the escape button on the unit, you'll eventually go back up to the top level menu. So if you go too far, when you're going back up levels in the menu, if you go back up too far, you'll eventually get back up to the home menu. So I'm just going to go back into results again, scroll down to the delay, and you can see now that I've got a round trip delay measurement going on here. I've only got a current measurement because I haven't actually pressed the run button on the unit. If I press the run button on the unit, then we will get a minimum and maximum value. Now there is, on any delay measurements, there is some accuracy, stroke jitter on the measurement. This is normally in microseconds. On the VF interface, it can be up to 100 microseconds, but when you're making measurements in the range of milliseconds, which you're normally doing for protection relays, that accuracy jitter is not really that relevant. And seeing they've just got, actually on this example, I've just got the unit loop back to to itself, then we're seeing that the current value is ranging between sort of 50 microseconds, 20 microseconds. Actually, the maximum here is 676 microseconds. That's what we'd normally expect when we actually connect. We would connect to the actual VF circuit and measuring the delay. Then obviously that measurement would be in the milliseconds, which is what we're normally interested in. Now, just for your information, you can see here we're getting a round trip delay measurement. We haven't got a forward path, return path, or a symmetry measurement because we're not doing a one-way delay measurement. That is only get those results if we've got the unit set for a one-way delay and we're testing between two units, one at this end and one at the far end. So that's very, very simply the delay measurement. So if I press the run button on the unit just to stop that test for a moment, I'm going to hit the escape key. Well, actually, I'm going to hit the home key, go back up to the top level menu. So now going to the test menu, and I'm going to disable the delay measurement. So now I'm not going to be making the delay measurement anymore. Going to hit the escape key. Now we're going to do a bit error rate test. So we don't actually need to change anything else. Let's go back to the home menu here. Oops, excuse me. The setup menu where we set up the Telecom endpoint mode, etc. We don't need to make any changes to that. We just go into the test menu, and we want to. Sorry, just go to the top level here. We want to go down. We're going to do a G821 performance test. We go into the performance test. We can select G821, for example. We can, if we want to, change certain parameters on the G821, but as standard, there's not much point in doing that. We're going to leave that as standard. And basically, that's it. We've just set it up now to do a G821 test, BERT test. So I'm going to hit run on the front of the unit, go back to the home screen and into results, and if I go into performance, then you can see here that I'm actually running a bit rate test. We've got no errors, and everything's good. I just actually disconnect the line for a moment and try and create some errors. Okay, you can see now we've had a couple of errored seconds, severely errored seconds, so that's for the moment is failing, but now I've reconnected it, so these percentages are slowly going to decrease over time, and if we left it long enough, those would go back into a pass state. But you can see that it's very simple, very easy also to do a bit rate test. Now, one thing I should mention here is that to do all this testing, as I said, I've got the VF adapter connected to the DTE port, Telecom DTE port on the bottom of the unit for the Ether.Genius. And I'm effectively, because on these BERT tests I'm using one unit, and on the round trip delay I'm using one unit, I'm effectively putting a loop on the VF circuit. Now in my case I'm just looping the cable locally, but if you actually connect it on a VF circuit, or for example you connect it to a couple of boxes using pseudo wire with VF at each end, at the far end of the VF circuit, or at the far end of one of the boxes on the pseudo wire circuit, you'd loop the VF back to itself, because obviously we're transmitting either a delay signal, or in this case a burr pattern, and we need to receive that burr pattern at the same end in order to make the measurement. There we go. That's very simply how to use the new VF test adapter for the Ether.Genius. As I say, this whole process and the way you use it is pretty identical for all different types of Telecom type interfaces, X21, V24, and also C3794.